AS Uses Exam Decision 2007, the very not official version. Haven't seen the mark scheme, just working through it the way I would if I was actually doing it. So, any dyslexic moments I'm quite willing to accept. So, first off, we've got A. It doesn't have anything that comes before it. It has a duration of 6. We then have B. Doesn't have anything before it and has a duration of 5. Then we've got part C. A comes first and is then 3 long. And very helpfully this year they've actually given us lines to work with, so we've got nice sensible boxes at the bottom that we can make, and they'll end up a decent size to be able to write in. Then we've got D, and D comes off from both B and C, so if we stick D over here somewhere, and D is coming with a duration of 1 and coming from B and C. E only comes out of C. So E just comes out of C. E has a duration of 3. F comes out of A, so if we put it up here, then it's out of the way. So things that will be important is the fact that these lines both come out from A rather than joining each other and then going across. Then we have G. So, F was a length of 1, so G comes out of F, E and D. So if G comes here, and that is 1, so that comes out of E, comes out of F and comes out of D, and H is the same. So if H goes here, and H is 3 long, and H comes out of D and E and F. I just comes out of C, so if we put I a little bit further across, so I can come out here, up at the top, out of the way. So I is 1, and that comes out of C. J comes out of D. And that was also 1. And then K comes out of all 4 of our left ones. So K comes out of H, out of I, out of G and J. And then once we've done K, we are at the end. Now we might not need an end box on the basis that we all go into K, but it's not the end of the world having it there. So that is 1A, construction activity network for the project. Part B, find the earliest start time and latest finish activity. Well, The earliest that these two can start is at 0. So if we come across here, starts at 0, takes 6, so the earliest that these two can start is 6. Then if we look at E, we've got 6 and 3. Earliest E can start is 9. So D, we've got 1 9 coming in, we've got a 5 coming in, so the earliest we can start is 9 because we have to wait for the slow people. So coming out on this side, we've got 9 and 3 is 12, 9 and 1 is 10, 6 and 1 is 7. So anything coming out of E is going to have to be at 12. So this one's at 12 as well. This one was 9 and 1 is at 10. The only thing going into I is C, so 6 and 3 is 9. Then everything that goes into K, the biggest one is going to be 12 plus 3, and 12 plus 3 is hopefully 15. 15 plus 1 is 16. And that gives us our earliest start times. Latest finish times are going backwards, so ending at 16. So deadline for 6K is 16. Deadline K gives to everyone also 16. And then working back. D gets given a deadline. No, they give 15. Concentrate. They giving at 15 because it takes 1. Okay, so 15 take 3 is 12. So the deadline that one's going to give is 12. 15 take 1. And the other one coming in is 15 take 1, which is 14. So the earliest deadline we've got is 12. So the deadline this one will pass on is going to be 12 take 1 is 11. So things that don't have that much going into them. We've next got F and E. So the deadline going into E will be coming from G and from H. So we've got 15 take 3 is 12 going in. So again, this one's going to have a deadline of 12. Deadline that gets passed back, 12 take 3 is 9, or 12 take 1 is 11. So that one's going to be 9. 9 take 3 is 6. And coming along here, we've got 15 take 1 is going to be F coming in at 12 from the 15 take 3. Yeah, that's fine. Okay, so that's the latest finish time. So critical path. Critical path is one where you're adding works. So 0 plus 6 is 6. So that is definitely critical path. 0 plus 5 is 11. That's not. 6, 3 is 9. So that one's critical. 6 and 1 is 12. So no. 6 and 1 is, sorry, 9 and 1 isn't 12. But 9 and 3 is 12. 12 and 1 isn't 15. 9 and 1 isn't 15. 10 and 1 isn't 15. However, 12 is 3 and 15. So our critical path is going to be A, C, E, H, and K. So if we then move on to drawing our Gantt chart, which is going to be on this page. This was a particularly unhelpful setup of the paper from the point of view that your network and your Gantt chart were going to be on different pages, so you couldn't see them. So looking across here, we need to get up to 16. So 1, 2, 3, 4, 5, 6, 7, 8. Realistically, we're going to have to do it in half squares if we want to do it that way. Or we've got how many lines in our table? 2, 4, 6, 8, 10, 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That can't go that way around. So we'll go this way. So that one's going to have to be 2, 4, 6, 8, 10, 12, 14, 16. And we've got A, B, C, D, E, F, G, H, I, J, K. So we have A, B, C, D, E, F, G, H, I, J, and K. Obviously don't have to start at the top, but it is neater. So for A, we start at 0. We have a duration of 6. So that is going to be 3 boxes, and we finish at 6. So that one is critical. B, we start at 0. We finish after 5. So that'll be 2.5 boxes. But we actually have to finish by 11, which is up here. So this first bit is going to be duration, and the second bit is going to be float, and have found ruler. So first bit duration of 5, and then the float with a dotty line. Then we've got C. C is starting at 6. It goes on for 3, which is a box and a half, and finishes at 9. It doesn't have float, wouldn't expect it to, it's critical. So D starts at 9. It is one little square, so finishes here. However, it can finish all the way up to 12, which is here. So first bit duration, second bit float. E also starts at 9, has a duration of 3, finishes at 12. F starts at 6, which is all the way back here, and is 1 long and finishes at 12. So we have a load of float to fill in. G starts at 12, goes up by 1, which is only one little square, but finishes at 15, which is here. So we have some float. GH starts at 12, is 3 long and finishes at 15, so just has duration. I starts at 9, which is way back here, only goes along 1, so the duration line finishes at 10, but the float itself will go all the way up to 15. J starts at 10, goes on 1, finishes at 15. And then K starts at 15, goes along 1, finishes at 16. So we've got our Gantt chart. Okay, so Tina needs a qualified electrician to draw it. He is 3 hours late. So 3 hours late, and we need to find new minimum time and critical path. So fountain to the electric cable is D. So D is 3 hours longer. So if we look at D isn't an hour anymore. We had 2 hours float. So D was 1 hour plus 2 hours float. And we've got a delay of 3 hours. So 2 of those 3 hours are going to be taken up in the float. So we end up having an overall delay of 1 hour. So it's 3 hours, take away the 2 is 1 hour. So D becomes critical. And because D is now critical, it pushes everything back. So our new critical path, we previously had an end of 16, so we have a new end which will be at 17 because we've got 2 hours float, so we're only having to add on an extra 1. And instead of E being critical, D now is. So our new path, our new critical path is going to be A, C, D, H and K. So whereas previously this one was critical, this one's now going to be longer. Okay, so question 2. We are using Dijkstra and we are going between MF to PP, temporary labels, state the route, minimum time. And we have got the no, that's Chinese postman, ignore me. So we are going from MF to PP, and this is Dijkstra. So Dijkstra, we've got a 0 at the beginning, and then we get into the steps. So box the smallest, 1 step in each direction. So 1 step is 14, 1 step is 8, 1 step is 13. Box the smallest and 1 step in each direction. So 8 plus 7 is bigger than 14, 8 plus 3 is 11. So this was a temporary label and it's been changed, and 8 plus 14 is 22. Box the smallest, which is 11, 1 step in each direction. 11 plus 8, bigger than 14. 11 plus 7 is 18. 11 plus 8 is 19. Box the smallest, 14. 14 plus 8 is bigger, and that's all we can do. Box the smallest, 1 step in each direction. 18 plus 3 is 21. 18 plus 8 is bigger. Box the smallest is 19. 19 plus 10 is 29. 19 plus 10 is 29. Then we can box the smallest at 21. 21 plus 5 is 26. 26 plus 4 is 25. Box the smallest, can't go anywhere. Box the smallest and stop, because we've got to the end point. So 26 should not be boxed. So our root was 25 take away 4 is 21, 21 take 3 is 18, 18 take 7 is 11, 11 take 3 is 8, 8 take 8 is nothing. So we have a root that is 2a goes mf to bp to pa to ug to po to pp. It is 25 minutes long. So we've stated the route, we've done the minimum time, we've left our temporary labels where we've crossed them out. And B, slightly weird algebra bit. So we are considering changing our route. So if we walk directly between MF and SS, so if we go from here to here, that is X. So for 2B, we know that if we go from MF to SS, that is equal to X. So by walking directly between these, the minimum walking time is reduced. So this is now reduced, so this is less than 26, because we know we can get there in 26. However, the minimum walking time from MF to PP, so going MF to PP, what we'd have to do, that is going to be MF goes to SS goes to PP, so that is X and that is 5 because we're going along that route there, and that is not reduced. So that tells us that getting here, it's not quicker to do this route. So we know that X plus 5 is greater than or equal to the 25 that we've got here. So X is greater than or equal to 25. No. So if we take the 5 off both sides, we end up with 20. So we know that X is going to be bigger than or equal to 20, but less than or equal to 26. And that gives us our range. Right, so we have a walking tour. So we want a Chinese postman. And we want start and finish is the same. And we also know that our total is this. So first off, we need to identify our odd nodes. So our odd nodes are, this one has 3 coming out, this one has 3 coming out, this one has 5 coming out, and this one has 5 coming out. So these are our odd nodes. So 3A, we have odd nodes, and they are MN, BA, MF, and BP. Then we need to pair them up. So we could have MN with BA. We could have MN with MF, or we could have MN with BP. So those are all the options that we could have for MN. So MN to BA is 8, MN to MF is 9, and MN to BP is 14. So for each of these sets, there is another one that goes with it. So if you've used MN and BA, what you've got is MF and BP left over. With the second one, you've used MF, So you have BA and BP left over. Third one, you've used BP, so you have BA and MF left over. So MF to BP is 8, so that is 16. We've got BA to BP, which is 9, so that's 18. And we've got BA to MF, which is 1, so that is 15. So that is our shortest. So for our Chinese postman problem, we have Chinese postman problem equals 96 plus 15, which is equal to 111, and these are in minutes. So we've found the length, which is what we need to do. So second bit, we have a different person, and this person starts at one place and finishes at a different place. We need to state where he starts and finishes, and we need to find the length. So actually we've done most of the work for this already. So we can look at all of these pairs. We want the smallest, so that is this individual section. So what that tells us is we want to start, we need to end, we need to repeat. So if we want to repeat BA, MF, because that is 1, then we've got the other 2 options as our start and finish. So we can start MN, finish BP. So our Chinese postman problem is the 96, which was our total, plus the 1, which is our repeat, which gives us 97 minutes. And that was for 3 part B. Right, so this is a travelling salesman problem, and it's done in an interesting kind of way. So first off, we want to know the length of this tour. So it is specifically this tour that we want. So going from BA to SC is 15. Going from SC to PA is 8. Going from PA to PP is 14. Going from PP to SS is 5. Going from SS to MN is 17. And then going back to BA is 8. So for A part 1, we just need to add those things together. So we have 15 plus 8 plus 14 plus 5 plus 17 plus 8, which gives us 67. So working with table 1, in the bit opposite, use the nearest neighbour, starting, so nearest neighbour, starting from BA, find another possible tour. So if we head over here, if we start at BA, we've got BA, which we've been to, and the closest thing is MN, which is 8. So from NN, the closest thing we can go is this 15, and that is PA. BA we've been to, SC we haven't, So SC is that 8 because 8's the smallest on that one. SC, we've been to PA, then we've got the 15s, been to BA, not been to PP yet. So if we head to PP at 15, PP, haven't been to SS yet, that was 5, and SS, so we've now been everywhere, so we are going to head back to BA, and then we can do this with adding, and hopefully we should get something. SS to BA was 17, and that we've got 68. So, realising there's a question on the next page, we are asked to do prims on tables. So we want prims starting from MN. And we want a minimum spanning tree. And we want the order in which we select the edges. So, if we start at MN. So MN is our first thing. So we are not going to have to go back to MN. And we know about everything in MN. So we can pick the smallest. So the smallest one we've got is MN to PA is 15. So PA is the second place chosen. And if we want to do the tree as we go, we've got MN to PA. So we don't need to go back to PA because we've already been there. But we do now know about PA, so we can choose stuff from here too. So the smallest thing that is currently highlighted in either of these two columns is this 8. So that is PA to SC is 8. So SC comes from there. So once we've been to SC, we do not need to go back there. It was the third one that was chosen. And we now know about what's going on in here as well. So, looking round, we have this 14. So we have PA goes to PP. Fourth one chosen was 14. Don't need to go back to PP because we've now been there, but do know all about it. So we can choose this one. So PP to SS is 5. So PP to SS. From a table point of view, we've now been everywhere, so they won't complain if we don't put a 5 there. They won't complain if we don't cross this one out. So we're just looking at adding. So 22 should be 42. So we've shown the order which we selected the edges. We've got them as a list. We've got a minimum spanning tree, and we know how big it is. Hence, in exam world, hence basically means use what you have just done. And we want a lower bound. So our lower bound is going to be the minimum spanning tree that we've got. And then we are going to add on our 2 smallest from what we've got left. So the 2 smallest from BA is 8 and 9. So plus 9 plus 8. So that would have been BA and that would go to PA and MN. So PA and MN. So in total, that gives us 59. No, 59. Okay, by deleting each of the other vertices in turn, we have some more lower bounds. And so we are told our tour is t minutes. We're using parts A and B, and we want the smallest interval. So we know that t is going to be between our upper bounds and our lower bounds. Now our upper bounds we did on the previous set in part A, so we've got two upper bounds, 67 and 68. So the ones that's going to squash it in smallest is going to be the 67, because the 68 would be over here, and so you'd actually have a bigger section. And the lower bounds, we've got 59, but we also have 60. So this interval here is going to be the smallest interval that we can get.